Hello, grade 9 students. This is our fourth lecture. We're going to start by a new lesson. It's actually the beginning of our lesson, which is real numbers. So we first talk about numbers and calculations. Those are from last year, from grade 8. So I'm going to make a revision, and then I'm going to start with the real numbers. So what I'm going to start by first the kinds of numbers. We're going to learn what are the natural numbers, integers, decimal numbers, real numbers, rational and irrational numbers. Then we're going to remember together what are the opposite numbers, what are the reciprocal numbers, the prime numbers. We're going to find GCD and LCM. How can we get the irreducible fraction, and how can we round or approximate a decimal number. We're going to remember together how do we solve literal fractions and compound fractions. So let us start with the kinds of numbers. The first number, or the first set of numbers, because it's not actually one number, it's a set, it's a group of numbers. We call them the natural numbers. So what are the natural numbers? Are all the positive numbers, or the only numbers that don't have a decimal point. So it's not a decimal and it's only positive. So numbers are 0, 1, 2, 3, 4, 5, 6 till you reach the plus infinity. So only the positive whole numbers. Whole numbers means it's not a decimal. Then the second group of numbers, the second set, is the integers. What do I mean when I say the integer? It's all the positive and negative numbers that do not contain a decimal point. So you can say that natural numbers are part of integers. Why? Because a number could be natural and could be integer. Like for example, if you have 10, it's a natural number because it's a positive whole number, and it's also an integer because it's a positive whole number. So the natural numbers only contain the positive numbers, while the integers contain the positive and the negative whole numbers. Now the third kind, or the third group, it's the decimal numbers. What do I mean by the decimal numbers? Are all the numbers that contain a decimal point in their digits, like 38.627. It's a decimal number because we have two parts, the whole part, which is 38, and 627, which is the decimal part, and they are separated by a decimal point. And now we have the real numbers. The real numbers, you can tell that it's the universal set. It's the universal set. What I'm trying to say is that the set that contains everything. It contains the integers, the decimals, the natural numbers, and you can classify the real numbers into two groups. The first group, which is the rational numbers, and the second group, which is the irrational numbers. So the real numbers are decomposed into two groups, the rational and the irrational numbers. The rational numbers are the numbers that you can write them as fractions. So any number or decimal that you can write it as a fraction, it's called a rational number. Like for example, 9. 9, it's a natural number, it's a integer, and it's also a rational number. Why? Because you can write 9 as a fraction, which is 9 over 1. 0.2, it's also a rational number because you can write it as a fraction, which is 1 over 5. And radical 9, of course, it's a rational number because you can write it as 3, and 3, it could be written as 3 over 1, so you can write it as a fraction. Now the irrational numbers are the numbers that can never be written in the form of a fraction. Like for example, pi. You know that pi, it never ends. It's a decimal that never ends, so you cannot write it as a fraction. Also, radical 7, if you put it on the calculator, it's 2 point something that never ends, so you cannot write it as a fraction, so it's an irrational number. Although radical 9, it's a rational number because it's actually 3, but radical 7, it's an irrational number. So not all the radicals are irrational, so you have to pay attention to this. Now, some decimal numbers, although they never end, as I said before, but it has something special in their decimal part. We call it a periodic decimal part. What's the meaning of periodic decimal part? It's a decimal part that have a specific a number that's repeated. Like for example, if you know 0.2222, it's actually 0.2 bar. This number, although it never ends, but it's not an irrational number. It's a rational number. Why? Because I can express this number as a fraction. Also 1.26, 26, 26. So as you can see, 26, it's repeated many times. So it's a periodic decimal part. So it's 1.26 bar. So you can write it as a fraction. I'm going to teach you how do you change those decimal numbers into fractions, but you have to pay attention that not all the endless or unlimited decimal parts are irrationals, because there are some special endless decimal part. Before I teach you how do we change this decimal into a fraction, let us just look at this map. It's a sketch that indicates that the real numbers is the mother set, because it contains everything. It contains the irrational, which takes a big area of the real numbers. We have the rational numbers that can be written as fraction. It could be an integer, it could be a whole, or it could be a natural number. And I told you that the natural number, it's a part of the integer. Okay, let us look at the second drawing. Also here you can see that the real numbers contains everything, contains the irrational numbers and the rational numbers. And parts of the rational numbers are integers. Part of the integers are the whole numbers. And part of the whole numbers, it's in natural numbers. What's the difference between natural and whole numbers? That only whole numbers contain 0. And natural numbers also, they contain 0, but they have no point, both of them, okay? And now I'm going to teach you how do we change decimals into fractions. Well, 0.5, it's very easy. You know that this is a rational number. Why? Because I can change it into a fraction. 0.5, it's 5 over 10. And 5 over 10 is written as 1 over 2 in the irreducible form. So this decimal, it's a rational number because I can write it as a fraction. Also 0.48, you know that it's written as 4800, so it's 48 over 100, and its irreducible form, it's 12 over 25. 2.4, it's written as 24 over 10, so I can write it as 12 over 5, so it's also a rational number. Now let us start with the periodic decimals, those numbers that have in their decimal part a number that's repeated many times. I'm going first to start by 0.6 bar, which is 0.6666. How do I change it into fraction? It's very easy. It's just you can put 6 over 9. Why did I choose 9? Because if it was 10, then I'm going to get 0.6. But what makes it periodic in this rhythm, it's 9. Why did I choose 9, for example, not 99? Because the number repeated is 6, only 6. So if only one number is repeating, then it's over 9. If two numbers are repeating, like in the second example, you can see that we have 0.12 bar. So the number which is repeated is 12, 12, 12. So you put 12 over 99. Why did I put 99? Because I have two numbers repeating. What if I have three numbers repeating? So it's 999, as you can see in the third example. So we put the number repeating, which is 312. We put it on 999 because it's 3 digits that are repeating. Also, if I can write it in decimal form, in the irreducible form, of course you can write it. Now, what if I have 1.6? You have to write the whole part, which is 1 alone. 1 plus 6 is repeated many times, so it's 6 over 9. After you write it in this form, you have to make them with a common denominator. So 1 over 1, and you do the same denominator, and now you get 15 over 9, which is 5 over 3 in the reduced form. Now 3.45 bar, as you can see, I'm going to split the whole part and the decimal part. So the whole part 3 and the decimal part 0.45, 45, 45. So the number repeated is 45. I put it over 99, as you can see here. Also, I do the same denominator and I then add them, then reduce them. Now what if I have 1.28686 bar? So I have only number 2 and then 86, 86, 86. How do I split this? As I told you before, you're going to put the whole part, which is 1 alone. So it's 1 plus, and the number which is found only once, which is 2, I'm going to write it 0.2. It's in the 10th place. I write it just like as expanded form. So 1.02 plus 0.086 bar. This, you know that the number which is repeated is 86 here, okay? So 1 alone, which is the whole part, 0.2 also alone because it's not actually repeating with the 86. And I leave the 0.086 alone. Now 1 and 0.2, they are going to be copied. Now how do I write this as a fraction? It's very easy. It's 1 plus, you know that 0.2 is 2 over 10, 86 over 990. Why did I put this? Because 86, it's repeating many times, so this is 99 for the 86. But here I have 0. What do? We put it beside it, so it's 990. And now I do the same denominator and I add the fractions. Okay, now the same thing here. What do I have? 27.385 bar. So if you want to split, I have here 27, we write it alone, plus 0.38 alone, plus 0.005 bar. How do I write this? It's 27 plus 38 over 100 plus 5 over 900. Why did I put 5 over 900? Because the number is repeated, it's 5. That's why I put here 9. And here I have 2 zeros, so I have to put 900, as you can see. And also I do the same denominator for all the fractions. And now we go for the second set, which is the opposite numbers. What do I mean by opposite numbers? Two numbers are said to be opposites if they have the same numerical part but with opposite signs. Like 5 and -5. They have the same numerical part, which is 5, but one of them is positive, the other is negative. There are some properties that you have to know about opposite numbers. The opposite of a positive number is a negative number, and also the opposite of a negative number is a positive number. The opposite of 0, it's 0 because 0, it doesn't have any sign. And the sum of two opposite numbers, of course, it's 0. Like, for example, -10 and 10 are opposite numbers. Radical 5 and minus radical 5 also are opposite numbers. Now, reciprocal of a number. What's the meaning of reciprocal? It's the inverse of a number. So what's the inverse of A? Is 1 over A. What's the reciprocal of A over B? It's B over A. So every time you multiply the product, if you multiply those two numbers, the number with its inverse, you're going to get 1. Like 2 and 1 over 2 are reciprocals. If you multiply 2 by 1 over 2, you're going to get a 1. Also 5 over 7 and 7 over 5 are reciprocals. So if you multiply those two fractions, definitely you'll get 1. Now the prime numbers. Prime numbers are all the natural numbers that have only divisors, two divisors. What are they? 1 and themselves. Like, for example, if you take 19, 19 it cannot be divided only by 1 and itself, so it's a prime numbers. The prime numbers are 2, 3, 5, 7, 11, 13, 17. So as you can see, 2, it's the only even prime number. 0 and 1 are non-prime numbers. Why? Because we said that 1 and itself, but 1, it's 1 times 1. So 1, and it's not, you cannot say that itself because both of them are 1. So it's not presented as prime number. You have to pay attention. This is a common mistake between all students. They pretend that 1 is a prime number. It's not a prime number. And 2, it's the only even prime number. Now, how do I find the GCD and LCM of two numbers? Suppose you have two numbers, 48 and 60. How do I find the GCD and the LCM? You write 48 and 60 as prime factors. So 48 is 2 to the power 4 times 3. How do I do this, by the way? You do the prime factorization. And 60, it's 2 squared times 3 times 5. Then the GCD of those two numbers is 2 squared times 3. How do I get the GCD? It's when you find the common prime factors with a smaller exponent. And how do you find the LCM? You multiply the prime factors, all of them, even if they are common or not. But if they are common, you take the larger exponent. So it's not like the GCD. Now, the irreducible fractions. So what's the meaning of irreducible fraction? It's a fraction that cannot be simplified anymore. Like, for example, if you have 48 over 60, you write 48 as prime factors and you write 60 as prime factors. Then you simplify until you get 4 over 5, which is the irreducible fraction. How do you simplify? It's very easy. You just multiply. For example, 3 is crossed with 3. 2 to the power 4 over 2 to the power 2. What's left? It's 2 to the power of 2, which is 4. And 5, here you go with the 5. So it's 4 over 5 in the irreducible form. Now, how can I deal with the literal fractions? Like, if I have two fractions, I want to add them. If you want to add them, you have to make sure that they have the same denominator. In this case, they don't have the same denominator, so I need to make them the same. How? I multiply the first fraction by the second denominator, and I multiply the second fraction by the first denominator until you get the same denominator. Then you can add the numerators and you keep the denominator. The same steps in the subtraction, you have to do them with the same denominator. Now, in the multiplication, it's not the same. You have to simplify. It's no need to have the same denominator. So the minus goes with the minus. 6 divided by 3, it's 2. And a squared over a, what's left is a. Now b goes with the b, and what's left down, it's the c. Okay? What if I have division? In the division, it's keep, switch, and flip. What do I mean? It's we keep the first fraction as it is, we switch the division into multiplication, and we flip the second. What's the meaning of the flip the second? We find it's reciprocal. So it's upside down, and then we do the same steps as the multiplication. Now, the most important one, if I have compound fraction, like if I have two fractions under each other. It's very easy. It's the first fraction divided by the second fraction. What you do first is applying the pandas. You start by the parentheses, you find its value, and then you do the same denominator and you get 33 over 10. Now, also downward, you do the same denominator until you get 3 over 10. So now what do? It's 33 over 10 times, because when you have division, you flip it into times, d over c. So you flip the second fraction. And then you apply 33 divided by 3, it's 11. The 10 goes with the 10, and what's left is 11. Now, how do you give an irrational number an approximate value? Like, for example, if you have radical 11, just use the calculator to find radical 11. It's 3.3166247. It's unlimited and it's not periodic. So how can I write this approximation? It's very easy. If I want you to find this value to the nearest 10 to the power minus 1, that means I have to round it to the nearest tenths. What do I have in the tenths? I have 3. What do I have just before 3? I have 1. Like, I'm going to annotate it just a second. We have here 1. Okay, the 1, it's below 5, so the 3, it's not going to be changed, so it's 3.3. So you have, for example, 3.14159265. I want it to the nearest 10 to the power minus 2, to the nearest hundreds. So you stop here. The 1, it's not going to be the 4 is not going to be changed because I have 1 just before it. That means it's 3.14. So at the